Yeah, out here, early morning, hear the birds chirping. So let's talk about hold on, turn the camera around. See that moon? See that moon? Yeah. So let's talk about the periodic table, right? We know that you have solids, liquids, and gases, right? And you have the weight of the states. You have atomic weight, meaning an oxygen atom weighs this amount. A hydrogen atom weighs this amount. A gold atom weighs that amount. You understand? And the lighter it is, it floats on top of each other. Like you take water and you put oil in the water, the oil floats on top of the water, right? So when you see the moon, right, in the midst of the air, meaning wherever the moon and the sun is, it's light enough to where it's that high or it floats on the air. You understand what I'm saying? That whatever makes up these lights in the sky is lighter than air. That's why it's up there. Because in the Bible, it says that the sun, the moon, the stars, and all of the host of heaven is within the firmament. Meaning it's not up there floating in the waters that's above the firmament. You understand? It's not floating in something to say in space, right? Zero G, right? So the sun and the moon, they're floating because they weigh less than air, right? It's similar to a helium balloon. A helium balloon is lighter than air, plus it's lighter than the air plus the material which is in the balloon casing, the plastic, right? So it floats. So I just want to bring that up because the sun and the moon float within the firmament. You understand? There's no such thing as zero G space. You cannot take a rocket, right, and make it go high enough to the height of the moon, and then you turn off the rocket and it just floats. The rocket is heavier than the air. It's gonna come back down. Anything that goes up that's heavier than the air must come back down because it's heavier than the air. The air cannot support it. You understand? That's why the moon and the sun can just be up there like that because it's lighter than air. So no man ever landed on that. How can you land on something that's lighter than air with no casing, right? Nothing to hold it in. Man might say, oh, you look into a vacuum chamber and you take the air out of the vacuum, a helium balloon just drops to the ground. And they'll say, see, flat earth is stupid. Zero gravity, you're stupid. But I'm like, listen, the helium is lighter than the air. Air is lighter than water. If you take an empty balloon of just air, right? Regular air, oxygen, nitrogen, you know what I'm talking about? Air. And you put it in water, it's gonna float up. It won't go in the water, it will float up of the water, right? No. Is the balloon filled with regular air, right? Is it defying the gravity? No, it's floating on the air. But it's float like a helium balloon floats on the air, and a regular air-filled balloon floats on the water because air is less dense than water, right? So when you deflate the vacuum chamber, there is no air. Hold on, stuff in my eye. When you deflate a vacuum chamber with a helium balloon in there, right? The helium in the balloon has nothing to buoyance off of, to be less. It has nothing to be less dense than. You understand what I'm saying? It has nothing to lift on. Same way a boat, right? A boat on land has nothing to lift it, so it just steps on the land. But put water, no, you understand? The boat can overcome the water and float upon the water because of the surface space of the boat, right? It can overcome that. So you have things that's heavier, but since the surface area of what's in contact is greater than the weight where it can push down, it steers up, the buoyancy, right? So, same way with the sun and the moon, right? Either they have something that's lighter than the air, or it's buoyancing off of the air, and it's not buoyancing off of the air. It's lighter than the air. That's why it can just be in the air like that. You understand? Yeah.